Error handling is an essential aspect of programming that allows developers to manage and respond to unexpected situations in their applications. In this lesson, we will explore how to implement error handling in Python applications. Understanding error handling won't only help you create more robust applications but also improve your debugging skills, making it easier to identify and fix issues as they arise. Don't worry if this feels new at first. Now we're on understanding exceptions. In Python, an exception is an event that disrupts the normal flow of a program's execution. When an error occurs, Python raises an exception. If not handled, this will cause the program to terminate. Common exceptions include: first, value error, raised when a function receives an argument of the correct type but an inappropriate value. Also, type error, raised when an operation or function is applied to an object of inappropriate type. Finally, index error, raised when trying to access an element from a list using an index that's out of range. Now, using try and except blocks. The primary way to handle exceptions in Python is through the try and except blocks. The code that may cause an exception is placed inside the try block, while the code to handle the exception is placed inside the except block. Here's a basic example. I'll let you read the examples on screen rather than reading every line aloud. In this example, if the user inputs a non-integer value, the value error exception is raised, and the message that's not a valid number is printed instead of crashing the program. Now we're on multiple exceptions. Sometimes you may want to handle multiple exceptions differently. You can do this by specifying multiple except blocks. Here's an example. The samples on screen walk through this step. Take a moment to read through them. In this case, if the index is out of range, the program will print index out of range instead of crashing. Finally block, let's dig in. The finally block can be used to execute code regardless of whether an exception occurred or not. This is useful for cleanup actions. Here's an example. I'll let you read the examples on screen rather than reading every line aloud. In this example, the file will be closed whether the file was found or not, ensuring that resources are properly released. Next, raising exceptions. You can also raise exceptions intentionally using the raise statement. This can be useful for validating inputs. For example, this sample defines a function. Review the implementation on the slide. In this example, calling check_positive with a negative number raises a value error with a custom message. In this lesson, we covered the basics of error handling in Python. We explored, first, what exceptions are and why they occur. Also, how to use try and except blocks to handle exceptions. Also, how to handle multiple exceptions with different except blocks. Also, the utility of the finally block for cleanup. Finally, how to raise exceptions intentionally to enforce rules. By implementing these techniques, you can create more resilient applications that handle errors gracefully. Go ahead and work through this exercise. First, create a program that asks the user for their age and raises a value error if they enter a negative number. Also, modify the file handling example to include a try block that opens a file for writing and catches any potential I/O error. Also, build a function that takes a list and an index, returning the item at that index while handling index error appropriately. Finally, experiment with raising a custom exception in a scenario where user input is invalid.